driverless trains have become a symbol of modern urban mobility, with systems like those in London, Singapore, and Shanghai operating with minimal human intervention. These systems are typically confined to closed metro environments, where variables such as track conditions, passenger flow, and external interference are tightly controlled. The question remains, can this technology be extended beyond these controlled environments into more complex and open rail networks? This episode explores the potential for driverless trains to move beyond closed metro systems, examining the evidence, limitations, and real-world implications. Can driverless train technology, currently confined to closed metro systems, be successfully expanded into broader public transport networks?
Technologies, real-time passenger information, and increasingly, driverless train operations. The subway system has become one of the most significant elements in the evolution of modern urban transportation.
Modern subways are adopting driverless trains, but can this trend expand to open rail networks? Today, driverless trains are already in use in subway systems like the London Underground and the Tyne and Wear Metro. These systems use automation to improve efficiency and safety, with some lines operating with no drivers on board, only attendants. In the future, a city might expand its driverless metro to a suburban rail line, requiring major infrastructure upgrades. Public reassurance would be essential to ensure safety and reliability as automation expands beyond subways. Imagine a world where driverless trains operate seamlessly on open rail networks, connecting cities with minimal human intervention. However, expanding this technology to open rail networks presents challenges, including unpredictable weather, track conditions, and passenger behavior.
Of the subway. One of the main advantages of the subway system is its capacity to transport vast numbers of passengers within short periods, making it one of the most efficient forms of public transportation.
Can driverless trains scale in complex urban environments? Subway systems are already highly efficient, moving large numbers of passengers with minimal delays. Research shows that driverless train systems are in use globally, with over 64 fully automated lines across 42 cities. These systems offer benefits like lower operation costs, increased capacity, and energy efficiency. However, in cities like London, the transition to driverless trains faces significant challenges, including high costs and safety concerns. In the future, driverless trains could operate on high-frequency commuter lines, improving capacity and reducing delays. Automation might allow for seamless integration with other transport modes, creating a more efficient urban mobility network. Advanced safety measures and coordination could ensure that driverless trains function reliably even in unpredictable conditions. However, the transition to fully driverless systems in complex urban environments like London would require significant investment. A TfL report estimates that upgrading 3 of the oldest lines to fully driverless would cost at least £20 billion. The evidence suggests that while driverless trains have proven their worth in closed metro systems, their expansion into broader networks is not yet a certainty. Technical challenges, such as dealing with unpredictable environments, and social concerns such as public trust and safety, remain significant barriers. However, with continued innovation and selective implementation, driverless trains may gradually become a more common feature of urban transport. The future of driverless rail is not yet fully realized, but it is not entirely out of reach.